constructor is called every single time an animal object is created. So there we go. And it's going to be called animal. It's going to get this right here, int weight string name, and this is basically going to do exactly the same thing that this does. Let's just go in there, paste it in there, and you can see that basically setAll does exactly the same thing that the constructor does, so there's no reason to put that in there. I just did it just so I could show you another function inside of there. So let's just get rid of this to show you that regular functions and constructors all are the same. For the deconstructor, we're just going to go animal, 2 colons, ampersand, animal, doesn't receive anything, and then we could come in here and just put a message out, animal, and we get the specific animal name, put this in there again, name, and destroyed, just so that we have a message on the screen to see what's going on. We have our overloaded constructor that's going to be called whenever no attributes are passed in. Again, animal, animal, it's still a constructor, no attributes, and in this situation we could also call that we have created another animal. Then we have the toString, where's that at? There it is, see, just void toString. Let's come down here and declare that, void, doesn't get anything, animal, class name, toString, doesn't receive attributes, and here we could come in and just print out all the information we have on our animal. Is, and get the height for our specific animal object, jump down to the next line just to keep this neat, centimeters tall, and this, get the weight for it, kilograms in weight, and just close that off. And then we'll be able to go down in main and start creating an animal object. So to create this, let's say we want to create an animal named Fred. We could then go into Fred and set his height to 33, set his weight to 10, and set his name, of course, to Fred. Right, like that. Just created a new Fred animal. We could then get the values back from it by going Fred dot get name is, we're not using this here, just to show you the difference between trying to get the data from inside of the class itself and then trying to get it somewhere else. Centimeters tall, and Fred get weight, kilograms in weight. And there we are. And we could also come in and use our constructor in this situation. Here we are using the default constructor that doesn't get any attributes, and here we'll use the constructor that does get attributes. So we'll pass in 36, 15, and Tom, and then we're going to be able to also print out all the differences between Tom and Fred. Let's print that out, and then just change this to Tom. There's Tom, there's Tom, there's Tom. And made a little error here. Let's just jump up to set name, and let's make sure that we change this to a string and not an integer. Move a little bit too fast here sometimes, make little mistakes. And there's animal name. Let's also come down here and change this name and then change this to name. Alright, so there you go. Now you saw that we created a Fred and a Tom object. Let's go over and execute that. And there you can see Fred is 33 centimeters tall, 10 kilograms in weight. Tom is 36 centimeters tall, 15 kilograms in weight. And here you can see the destructor was called to destroy both those objects since we no longer need them. Now we can also come in and inherit all of the attributes and the methods that are created from the animal object, and instead use them in our dog class. So there we go. We just need to create a new dog class, and to inherit all the animal classes, we just put a colon and then public and animal. And that's all we need to do, and we have everything that is defined in the animal class. We could come in here, of course, and create some new ones. So let's say we wanted to have a sound string that is going to have the value of wolf. And then we could also come in and create a bunch of public methods that do some different things. One thing it's going to have to do is get the sound, and in this situation I'm just going to have that print out on our screen. So sound, there we go. Since we are going to have a sound in our dog class and our dog objects, we're going to have to declare a new constructor that's also going to get the sound. So int string and string, like that with that prototype. We could also come in here and declare a default constructor that's not going to receive anything, and then on top of that call the default superclass constructor, just like going like this, and there we are. And then we could also decide to overwrite toString, since we are also going to be printing out the dog's sound. That's all we're going to do there, and then put another semicolon here at the end, of course, very important for our class. And now we have to go in here and actually define everything that is going to change. So this is going to be the constructor for our dog, and it's going to get past the int height and the integer weight and the string name as well as the string bark. Now to reference the animal class here, I'm going to put a colon and animal, and we're going to say here that we want the animal constructor to handle the height and the weight since it handled it so well previously. However, I want in this constructor to be able to handle the sound part because sound doesn't exist in the animal class. And here we're just going to have it be bark. So that's a great way to have the animal constructor handle height, weight, and name because all those attributes are going to be shared and at the same time just change the thing that is different. Saves us some space. Also could come in here because toString also changed. So let's go in here and change it. And because the attributes like name and height and weight were private in animal, I'm going to have to use the get method to be able to access them. So I'm going to say this get name, right like that, is this get height, centimeters tall, and this get weight, kilograms in weight, and says, this is the thing that's different, jump down here, this sound. Okay, now I can demonstrate actually creating a dog object. So let's just go dog and let's call him Spot. We're going to pass in 3816. His name is Spot and the sound is going to be wolf. If I also just want to demonstrate using static methods here, go cout number of animals that were created, animal, and to call a static method you go get num of animals. I believe that's what they called it. Find out in a second. And I'm also going to be able to go spot dot get sound, and we could also go in and get Tom test to string, which basically does what all that other stuff did up there. Spot dot to string. And just to show you one other thing, we could also call the superclass version of a method by going animal spot animal and then putting 2 colons and string. And by the way, I keep calling this 2 colons. This is called the scope operator if you want to know what that's really called. And of course, at the end here, make sure we put our return statement with 0. And if we execute it, you can see there is everything. Number of animals that were created, you can see is 3 right there. And that includes Spot being the dog, as well as Fred and also Tom. So that's the reason why that showed up, and the reason why is the animal constructor was called every single time, whether a dog was created or animals were created. You can see wolf right here is this guy right here calling get sound. You can see we're calling toString on Tom to print out the information on that. We can see here that Spot also says wolf while the regular animal does not, and that automatically works. And here we're just demonstrating the use of calling toString, and in this situation Spot, whether he has a sound or not doesn't matter because we are calling the animal version of toString, and the animal version of toString only prints out the height and the weight as well as the name. And then finally you can see right here where the destructors are called and all of our objects are destroyed. Okay, now it's time to talk about virtual methods and polymorphism. I'm going to hold off on the definition for polymorphism here and instead create a new animal class. And it's going to have some public stuff that it does. And what it's going to do here first off is get family, which I'm going to refer to as a family of objects. And there's, let's just say we are animals. Close that off. And then this is where we get to virtual methods. I'm going to mark this as virtual and then I'm going to change it back from virtual. Basically we mark a method as virtual when we know that an animal, in this situation, will be a base class that may have this method overwritten by a subclass. And you're going to see it in action here. It'll make more sense when you see it in action. So, in this situation, I'm going to say, get class, and then I'm going to go, I'm an animal. Okay, so these are all in the family of animals, but the specific class for this is animal in this situation. And close that off. And now we're going to create a subclass called dog of type animal, or it's going to inherit from animal, and it's going to have public, of course it inherits everything, get class, and in this case I'm a dog is going to get printed out, and then close off that class. Now what we're going to be able to do here is come down inside of here, create an animal class, it's equal to new animal, and dog in this situation, new dog. Now in this situation, it's not going to matter if this is marked as virtual or not, because these are both references to animals and dogs. As you can see right here, I can just go animal dash get class and dog dot get class, right like that. Here I got the virtual part off of there. And here you can see if I execute this, I'm a dog and I'm an animal, both print there on the screen. If I was, however, going to try and call getClass from a function, you're going to see that we get some problems. So here we're going to say void, what class are you? And we pass in an animal object. They're both animal objects, remember? Well, you would think I'd be able to go animal, getClass, and get exactly the same results. However, as you're going to see, if I do that by passing in animal and dog, we don't get the results we expect. Instead, what happens is an animal gets passed in both times. If we want to be able to call the proper getClass for the dog and the proper getClass for the animal, all we need to do is come up here and type in virtual. And all that means is it's saying, hey, we expect this to change, so if you get a dog, whether it's an animal or not, why don't you go take a chance and take a look at if getClass resides in the dog class or dog object. And there you're going to see everything prints out exactly the right way. Now we're going to come up and create a couple more classes. Let's say that we also want to create another class, and let's call this German Shepherd, which is a little bit more specific. And it is going to be of type dog, and then we'll go in and type in public void and overwrite getClass with I'm a German Shepherd, Endel, closing curly bracket, and void getDerived, I'm an animal and dog, Endel, closing curly bracket, and now come down here and experiment a little bit more. See, basically polymorphism, all it means is whenever a animal is passed in this situation, like it did right here, we passed in an animal object, it's automatically going to find the right method to call. So that's basically it. Now there's many ways you can apply polymorphism, but polymorphism on its own looks like that. So let's create a dog object, and then let's create a German Shepherd and call him Max. The base class can also call derived class methods as long as they exist in the base class. So we're going to come up here, create an animal, it's a pointer to the dog, and to get a reference to Spot, we just put that little ampersand in there, create another one, and then point this to the German Shepherd. Get a reference to that with Max. We can now call the method that was not overwritten by any of the other classes. GetFamily, that's the same in animal. We could also call getClass, which was overwritten, and then come in here, change this to void, sorry about that. And then of course also close off our class with the curly bracket and execute it. And there you can see, we are dogs. We were able to call this guy properly. And then I'm a dog. See, this is a reference to dog Spot. And we were able to call the proper getFamily because this was listed as an animal. And also we were able to call the very specific class that resides in dog, even though these were listed as animals. Another example of polymorphism. Another thing that's neat is we can actually call the superclass, or German Shepherd, because everything is inherited. So we can call getFamily that resides in the animal class. And of course we can also call the overwritten German Shepherd version, Shepherd, and it's automatically going to go and get the right thing, as you can see right there. We are animals, and I'm a German Shepherd. So there's an example of using virtual methods, as well as a whole bunch of different examples on how polymorphism works. And then to finally get polymorphism 100% in your head, let's go and create an animal object, as well as a dog object, and a cat object that all inherit from the animal class. Now the animal is going to be a virtual method, again, because we're going to override it, and we're going to treat them as animals, because they are, curly bracket, and we'll say the animal says ger, basically going to do make sure you put that closing curly bracket on there, and then we're not going to copy the virtual part in this situation. In the dog here, we're going to say the dog says woof, and then the cat says meow. As homework, you could look into how you would actually set up an animal class as a capability class that exists only to be derived from. So look into that. There's your homework, because you guys ask for homework all the time. And now I'm going to also jump in here and give you an example of what an abstract data type looks like. So let's say we have a car, and this is more for completionist reasons than anything else. We could come in here and public again, virtual int get num wheels, the value is 0, and virtual int get num doors. And then you'd be able to derive this by coming in here and creating a new class called station wagon, inherit from car, even though car doesn't do anything, closing bracket, move that up, and then come in and define everything that we saw in the generic car, or the generic car abstract data type. Get num wheels has 4 wheels, like that. Close that off. And then we could go int get num doors, just like we defined up here in this abstract data type for car. Station wagon has 4 doors. And then we could also come in here and go station wagon, create an empty constructor and a destructor, right like that. Now let's jump down in main and play around with these guys. So we're going to create another animal here for our cat, and to do that we just call cat and animal dog, new dog, and we can see that if we call the cat specifically saying we want it to make a sound, and then we do the same thing with the dog, you can see that the cat says meow and the dog says woof, even though they're both set up as animals. And now let's go in and test our abstract data type with the car. Let's create a station wagon of type car. It's equal to new station wagon, right like this. And even though it is a car object, get num wheels, you can see that station wagon has 4 wheels, shows up there on the screen. So there's a whole bunch of different examples of polymorphism and a whole lot of information on C++. Hope you guys enjoyed this video. If you actually watched the whole entire thing, please leave a comment telling me so. I would really appreciate that. And please leave your questions and comments below. Otherwise, till next time.